In this lesson, we're going to be graphing square root inequalities and also doing their domain and range. So when we start this, you could graph these on your calculator if you want and use your table. I think what's really smart to do though is also find out a starting place. So if I put this on my calculator, y is less than the square root of 2x minus 6, I can put just that y equals part of my calculator. So I'm going to go to y is less than or equal, square root of 2x minus 6, and I hit graph. Here's the picture. So you can see that it looks like it starts at 3, 0. The interesting thing about this is when I look at my table, everything before 3 is an error message for a y value. That's because those numbers would make a negative under my square root, and it would make me have an imaginary solution which is not able to be seen by a graph. So 3, 0 would appear to be my starting point. Now, I just want to caution you because our tables don't do integers unless we ask them, or anything besides integers unless we ask them to. So we're not going to have decimals on there when I'm looking at the table. We can make that happen, but we're not going to. So now what I want to do is I want to make sure that my graph actually starts at 3, 0. This one, when I look at the graph, it looks like it is, but just so you have a backup, how you know where your graph starts. You take what's under the square root, so mine would be 2x minus 6 for this problem, and I set it equal to 0. Whatever I get for x here is my starting point. So I'd add 6, divide by 2, and I do get x to be 3. So 3 is where my graph starts. That's my starting point. So 3, 0. And then if I'm not sure what other points to plot, I can go to my calculator again and look at my table and plot those points that are listed there. So 3, 0, 5, 2 looks like a point we could plot, right? So let's plot 5, 2, and the rest aren't very good. How about 9 and 3.5? That's pretty close. That's a good estimate. So 5, 2, and then 9 and 3.5. So I'm going to go 5, 2, 9, and 3.5. So it's estimating it a little bit because I did graph a decimal, but it would work. So there's the sketch of my graph. Now what you maybe have noticed is that this is an inequality. So we're not done when we graph it. In fact, look at how I connected my dots. Right now, I just connected them, but remember it's a less than. So my less than or greater than symbol need to be a dashed line. So really, I got to redraw this now, don't I? I have to kind of put some dashes in there. So let me redraw mine. You can hopefully just erase quick on yours. Oops, it's 3, 0. 3, 0, 5, 2, and 9, 3.5. So here we are. I should have been dashed there. So you have to pay attention to that with inequalities. And then it says y is less than. So remember how I showed you on the calculator that anything less than 3 had an error message? I'm going to shade below this line, but I can't go anywhere past this line right here. So you almost want to draw that in and shade everything below here, but it's not going to penetrate that line of, we could draw the line in of x equals 3, that vertical line, and it wouldn't go past there. So from here, I'm going to list the set and interval notation. So I would say I am touching at 3, right? So I'm going to do a bracket for my domain, and then I seem to go on forever. For my range, if I draw on this line here, let's look at it quick. There's my range. I'm touching down here at negative infinity, right? And then I'm touching, well, again, this parabola should keep moving and widening, so it looks like I'm going on for positive infinity because it's going to keep widening and getting bigger. So I'm going to say I'm touching from negative infinity to positive infinity. My set notation then would be values of x such that x is greater than or equal to 3, or values of y such that y belongs to all reals. So you have two things you have to do here. Really, you have to be able to graph that on your calculator, and then you also have to pay attention to the shading and making sure that you don't go past this line right here. And that will be this. Every one of our graphs like this will have a line where our values would become imaginary numbers. So we're not shading on the graph because those aren't represented by a graph. Number 2, then it says y is greater than the square root of 3x plus 5. So I'm going to plot that on my calculator. 3x plus 5. So let's replace this with 3 x plus 5. So now when I hit graph, it looks like my graph starts at negative 2, right, if I look at the graph. So let's look at the table, second table. And when I look at my values, yep, negative 2 is an error. So my graph must not start at negative 2. And to be honest, I can't be sure it does anyways unless I take that what's under my square root and set it equal to 0 and solve. So I would have 3x plus 5 equals 0. 3x equals negative 5, so x equals negative 5/3. So my starting point for this graph is negative 5/3, 0. That's where I start. So I'm going to go back. Negative 5/3 is negative 1 2/3. So maybe like right here. Let me use red for you. And when you're doing this, I know you have to estimate, so you're just doing the best you can. As long as you can estimate like I am, you'll be fine. And then I'm going to look at my table and find some other points I can name. I'm noticing it's all decimals, so I'm going to try and find some that maybe I could kind of graph close. Like 1 and 2.8. Let's just try that one. 1 and 2.8. Maybe like right there. And let's do another one here. We'll go down a little bit. That might help. 5. Oh, 5 is pretty good. 5 and 4.5. So let's do that. 5 and 4.5. And maybe since this graph goes to 10, maybe I'll find one more, just so it's a better sketch, because I'm having to estimate so much. Ooh, look at that. 7 and 5. That's a pretty good one. So we'll plot 7 and 5. So now I look if it's dashed or solid. Don't make the same mistake I did last time, right? It's dashed. And then when I shade, it's greater than. So this line here, and you could draw it in almost as a dashed line also. You're going to shade everything above that. From here then, when I list my domain and range, since my starting point was negative 5/3, that's where my domain starts. Negative 5/3, and it ends at 0. Oh, I'm sorry, ends at positive infinity. My range starts at 0. And now this time it's going up, so it goes to positive infinity. So for my set notation, I'd say values of x such that x is greater than or equal to negative 5/3. And my range would be values of y such that y is greater than or equal to 0. Last one. This one looks really messed up on my graph. Something got shifted here, but you can see it on your notes. I'm going to go ahead and plug into my calculator. Same thing. I'm going to go to y equals. And I'll do second square root of, oops, no, I shouldn't have done the square root first, right? I should have done negative. How about that? Negative. Then second square root. So a lot of people sometimes forget to do the negative outside the square root. And then I'm going to go x plus 3. And then I close my parenthesis, but a lot of you who have the updated calculator, you'll arrow to the right, so your square root is no longer included on this, because this minus 2 cannot be under the square root. So when I hit graph here, it looks like my point starts maybe at negative 3, negative 2. I'm going to go to my table and look. Yep, right there, negative 3, negative 2. I think that's where it looked, but again, I have to go to my problem and take what's under the radical, set it equal to 0. So this is x plus 3 equals 0. So x equals negative 3. And so whatever x value works, the other ones it was 0 because we didn't have a number out here, right? But this problem is in vertex form in a way. And so I can actually take it and say that it's going to be negative 3, negative 2 based on that knowledge. Otherwise, you can plug in the negative 3. Negative 3 plus 3 would be 0. Square root of 0, 0. 0 minus 2. There's your y value. So you are starting at negative 3, negative 2. So I'm going to go and plot that point. And then I'm going to look at my table for some more points I can plot. I think you can definitely plot negative 2, negative 3, and 1, negative 4. So let's plot those. Negative 2, negative 3, and 1, negative 4. Let me find a few more just because I want to make sure I can get a good sketch here. 6, negative 5, that's a good one. 6, negative 5, so right there. So now I'm able to sketch it. Again, this is a dash. Nope, this one is solid. My graph just looks weird up here. This is a solid line, so I'm going to connect all the way through. And it's less than, so I'm going to kind of draw in a little bit of a dash, a line down here saying I can't go past that, and I'm going to shade everything down here. Remember, it's where we're going where y is going less than. So my domain starts at my starting point for my x's. So my domain starts at -3, and it goes on to positive infinity. My range starts at my starting point for my y values. So my range starts at, and in this case, since my graph is shaded below, it actually starts at -infinity, and then it goes to -2. So set notation would be values of x such that x is greater than or equal to -3, values of y such that y is less than or equal to -2. So take a look at those. Hopefully those all make sense to you. If you have any questions, the one thing that I will say comes up sometimes, and this is something you can kind of debate a little bit. Let's look at our first one. The fact that this is a dashed line makes people say, well, then this point might not be included, right, in my answer because this is a dashed line. So right here, when we say x is greater than or equal to 3, or if it was a y value greater than or equal, it's not actually touching at that point. So a lot of times you're really supposed to just say y is greater than 3 for those values of x, because since it's a less than and not a less than or equal to, it's a dashed line, it's not including that point. But you can write either way for what we're saying now. When we go more in depth with this, I will be more specific with it and we'll study it more. For now, it really can go either way.